All right, I hope that it went well. Here is how I would go about graphing this. And I'm going to put in my y-axis. I'm going to put in my x-axis. And so again, I'm going to run it through those three big questions. My big first one is there any time when I'm dividing by 0? And so basically what I'm doing is I'm looking at that denominator and saying, when does that end up being 0? So I'm basically just solving that. Add 1 to both sides, x is 1. So when x is 1, that makes that denominator to 0. I know I can't divide by 0, so that gets thrown out. So I know that I have a asymptote here at x is 1. X cannot be 1. I'm going to try and graph like a dotted line. I wonder if I can. I don't know why I'm... Oh, there they were. Then I don't have to try and freehand it and bother you with that. I could have changed the color. God, this is ridiculous. There. So there's an asymptote there. Can't divide by 0 when x is 1, asymptote there. So I know it's either going to come up towards it this way, or maybe it'll come towards it this way, something like that. All right, my next question is, what happens as x gets big positively, as x tends towards infinity, and also what happens as x gets big negatively, as x tends towards negative infinity? And so let's let x get big. If let's say like x is 100, that'd be 3 over 100 minus 1. 3 over 99, pretty small. Let's say x is 1,000, 3 over 999. Hopefully you can see that this is tending towards 0. And notice it's doing it from the positive side, right? X is positive, y is positive. We could do the same arguments with negative numbers. Start plugging in negative numbers. Plug in negative 100. It'd be 3 over negative 101. 101. Plug in negative 1,000. 3 over negative 1,001. Getting closer and closer to 0. So this would be an instance where it is getting closer and closer to 0. So that means that I also have a horizontal asymptote at y equals 0. Right along here. So I know now that my shapes are bounded in these regions. Could be here and here, could be here and here, could be here and here, but there's basically like one either in the top or bottom, one either in the top or bottom. So in order to graph it, I think I'll just grab some points and see what I could be. I'll plug in 2, positive 2 for x. Erase a little bit. So when x is 2, plug it in, I have 3 over 2 minus 1, which is 3. So when x is 2, y is 3. 2, 1, 2, 3. So I know it goes through this point. And I've already determined that it gets closer and closer to 0 from here. I've already determined that as x gets closer and closer to 1 from the positive side, it goes up towards positive infinity. Let me plug in a point here too. Let's say x is 0. When x is 0, 3 over 0 minus 1, which would be 3 divided by negative 1, negative 3, 0, 1, 2, 1, 2, 3. Same sort of thing. I know that as x gets closer to 1 from this side, this is going to tend towards negative infinity. And then as x gets big in the negative direction, that was horrible. As x gets big in the negative direction, this is going to get closer and closer to 0. I'm sorry I draw like an idiot when I'm doing this. X gets closer and closer to 0. So there's a good graph of it. And again, you can always use your graphing calculator, to check your work. I'll use Wolfram Alpha just because I don't have that emulator. But let's see, I had y equals 3 divided by, put this in parentheses, x minus 1. Hit enter. And notice on this graph here, I can look at it and see that it has this asymptote here at 1. right? It's getting closer and closer to 1 from top and bottom, and then it's getting closer and closer to 0 from both sides. Not too bad. Great. All right, so we've done a couple of examples. Let me do another example, and this one is going to be a slightly different looking graph. So we'll do y is, I'm sorry, I want to change the color. X plus 2 over x plus 1. All right, so if you were to graph that on your graphing calculator, you know, you have that screen that just comes up as y equals. You would enter parentheses for the whole numerator, x plus 2, close them off, divided by parentheses for the whole denominator, parentheses. Sorry. It was x plus 2 divided by x plus 1. There she is. Graph it. And it looks like there's some asymptotes in here, like one at -1 and maybe one at 1 or something like that. Well, we'll figure out what's going on with this horizontal one in a minute. But again, on your graphing calculator, there will probably be a line that like connects here to here. It'll actually draw that straight up and down line. The reason why your graphing calculator is doing that is it doesn't graph every single point. It calculates a point, then it goes over a certain amount, calculates the next point, and then it connects those 2 points. So what your graphing calculator did was it calculated the value for this point, calculated the value for this point. Since it didn't do anything between them, it just connected them. So, you know, it's a good tool, but know how to interpret it. So let's go back to this. Let's do our analysis. Again, 3 big questions, big issues. We cannot divide by 0. Can't do it. So I'm going to look at that denominator, and I'm going to say, when does that denominator end up being 0? All right. Subtract 1 from both sides. It happens when x is -1. So since I can't divide by 0, x cannot be -1. So that means that right here at x being -1, I cannot have a point there. X can't take on that value. That's basically given me this asymptote. It's given me this vertical asymptote right here. All right. Now, let's think about as x gets big positively or as x gets big negatively. And what I'm saying is x is tending towards infinity, x is tending towards negative infinity. So take a look at this, x plus 2 over x plus 1. Like let's say x is 10. I'd have 10 plus 2 over 10 plus 1, which is about 12/11ths. Pretty close to 1, a little higher than 1. Let's let x be 100. I would have 100 plus 2 over 100 plus 1, which would be 102 over 101. Close to 1, just off by like 1/101st, but it's closer to 1 than this is. Let x be 1,000. You got 1,002 over 1,001, even closer to 1. Here's what I want you to notice what's happening, and this is a really important point. When you're letting x tend to infinity or x tend to negative infinity, the thing to pay attention to is really just your highest powered x in your numerator and your highest powered x in your denominator. And here's why I'm going to argue that that's all that matters. When x is really big, this term and this term will dwarf all the other terms. So again, like let's say x is 1,000,000. 1,000,000 plus 2 or 1,000,000 plus 1, they both might as well be 1,000,000. And if that's not big enough for you, make x 1 billion. 1 billion plus 2, 1 billion plus 1. See, what's happening is as x gets really big, these little extra pieces lose their significance. These have a lot of significance when x is 0, when x is really small. But when x gets really big, who cares? You know, it's like Bill Gates drops $1 when he's walking down the street. Yeah, I don't know. I'd pick it up, but I'm not Bill Gates. He has so much money, $1. What does that mean? So what we can do is we can ask this question: what happens as x gets really big? What happens as x gets really big negatively? By just looking at x over x, which is just 1. So notice that what happens is as x gets really big positively, this thing gets closer and closer to 1 from above. So let me sketch in the asymptote, and I will be doing another example like this as well. So I'm not hanging out to dry here yet. Oh, that looks better. And kind of erase this work in here. So let's see. Let's see what happens when x is 0. 0 over 2. 0 plus 2 over 0 plus 1 is 2. When x is 0, this is 2. When x is negative 1, no, I'm just doing 1 to the left, 1 to the right of that asymptote. When it's negative 1, I have negative 1 plus 2 over, it can't be negative 1. Whoop, when it's negative 2. Negative 2 plus 2 over negative 2 plus 1. That's 0 over negative 1, which is 0. So when x is negative 2, y is 0. Ghost's going to go through those 2 points. And what's all pretty about this is we already know from our work before that as x gets big, this is going to tend towards positive 1. As x gets closer and closer to 0, that's going to tend towards infinity. I'm going to draw it. I'm going to draw it better, or maybe try to draw it better. That's awful. As x gets big negatively, this tends towards, that should be a nice curve, tends towards negative infinity. And then as x gets closer and closer to negative 1 from this side, that's going to get closer and closer to, that's going to tend towards negative infinity. Same sort of shape, kind of shifted up one, but there it is. I'm going to do another example like this. So I think that the new equation that I'm going to use is going to look a lot like the last one, but there'll be one little difference. So we can get at that. What happens as x tends towards infinity question again, and it's going to look like this. Y is 2x plus 1 over x minus 3. All right, so here's our questions, our big ideas. Can't divide by 0. Again, that's going to give us some vertical asymptote somewhere. So I would look at this denominator. When does that equal 0? Add 3 to both sides. It happens at 3. So I know that x cannot be 3. So I know that I'm going to have right here at 3, nice vertical asymptote. Next big idea, what happens as x gets big positively? What happens as x gets big negatively? So let's think about that. Same thing, as x gets really, really big in a positive direction, notice what happens is 2x is going to get really big, and the plus 1 matters less and less, right? When x is 5,000, this is going to be 2 times 5,000 plus 1. Who cares about the plus 1? And if 5,000 isn't big enough for you, go out to 1 billion. 1 billion times 2 plus 1. The plus 1 is insignificant. Same thing here. When x gets really big, the minus 3 loses its meaning. So what I can look at then is, as x gets really big, this basically tends towards 2x over x. which you can simplify. The x's divide out 2. As x gets really big, this thing tends to 2. So that gives me my vertical asymptote up here at y equals 2. Let me get it going. So now here's what I can do. I can start to sketch some graphing of it. Let's see, this is out here at 3. So let's say that x is 4. I've got, I'm going to move this up in here and do it up here. Sorry. X is 4. Plug it in. 2 times 4 plus 1 over 4 minus 3. Well, that was written wrong. It must be the day after the 4th of July. 2 times 4 plus 1 over 4 minus 3. 8. 9 plus 1. 8 plus 1 is 9. Oh, wow. It's when x is 4, this is up at 9. 1, 2, 3, 4, 5, 6. So it's way up here somewhere. So I'm not going to resketch the whole graph, but I'm going to say that I know that it's going to be doing something like this. And then let's say that x is 1, 2 at 2. So 2 times 2 plus 1 over 2 minus 3. So that's a 4 plus 1 over negative 1. 5 over negative 1 is negative 5. 1, 2, 3, 4, 5. So it's about here. And again, I know that as x getting closer to this is going to tend towards negative infinity. As x comes through here, that's going to tend towards that. And I'm not going to make a big deal about where the intercept falls. I could figure it out, let y be 0, and then solve it. But I just want a sketch of it, and I want to know where the asymptotes are. All right, so you just saw me do an example. So I'm going to give you a chance to do an example as well. So again, here's one that I want you to sketch a graph of. It's a lot like the last one that we did. 3x minus 1 over x plus 4. Get a sketch about it. You can do it on your own. You can discuss it with somebody else. That's great. But please get the practice in. Talk about it as a class. Maybe someone could volunteer to show how they did it. And then I'll come back and talk about it.